Hi students, in this video, let's discuss the questions that were part of the probability quiz. Before you go ahead and watch this video, make sure that you have attempted all the questions in the quiz. Alright, let's get started with the first question. Clara has to select a number at random from 2, 3, 4, 5 and 6. And Thomas has to select a number randomly from 8, 9 and 10. What is the probability that the product of the two numbers selected is even? Alright, what's the answer to this question? The correct answer is option C, that's 13 by 15. Let's see how to get this. Now, you know that probability is nothing but favorable events divided by total number of events. Alright, over here, Clara has to select a number from 2, 3, 4, 5 and 6, right? So she can do this selection in 5 ways because there are 5 numbers. So she can select any one of these 5 numbers. So that's 5 ways, or you can think of it as 5C1. Alright, and Thomas has 3 numbers from which he has to select one number. So he can do it in 3 ways. So the total number of selections that can be done is 5 into 3, that's 15 ways. Alright, now to find the favorable options among these selections, you just need to subtract the not favorable events from the total events. Now, the not favorable events is the case where both of them select an odd number, right? Because if both of them select an odd number, odd into odd gives odd, right? For example, 3 into 9, that's 27, which is an odd number. You can note over here that odd into even will give an even number. Even into odd also gives an even number, and even into even also gives an even number, right? So these 3 are favorable because we need an even number. So the not favorable case is when both of them select an odd number. Alright, now over here Clara has 3 and 5. There are these 2 options which are odd, right? So she can select an odd number in 2 ways. Now Thomas has only one odd number, that's 9 over here. So he can select an odd number in 1 way. So the not favorable events is 2 into 1, that's 2. Therefore the favorable events is 15, which is the total, minus not favorable, which is 2. So 15 minus 2 gives you 13. Therefore probability, which is favorable by total, is equal to 13. That's the favorable events divided by 15, which is the total events, and that gives you the answer as option C. Let's read the next question. Thomas and Ansa have 6 children. Alright, they are visiting their old friend Agnes after a long time. Agnes heard Thomas has 6 children. Agnes says to her husband, I am sure they must be having 3 boys and 3 girls. Help her husband calculate what probability Agnes has to be correct. Alright, so you need to find the probability that Thomas and Ansa are actually having 3 boys and 3 girls. Now, what's the correct answer to this question? The correct answer is 5 by 16, which is option B. Now, let's discuss 2 methods with which you could approach this question. Now, this is the faster method. Now, let's take the probability to get a girl child as 1 by 2 and the probability to get a boy child as 1 by 2. And it's 1 by 2 because they are equal, right? Probability to have a girl child is equal to the probability to have a boy child. So if you have a child, there is a probability of 1 by 2 for that child to be a girl, and there is a probability of 1 by 2 for that child to be a boy. Alright, now the probability to get 3 girls in 6 children, that would be, you can use the formula NCR P to the power R Q to the power N minus R. We've already discussed this, right? So if you want to have 3 girls in 6 children, N is equal to 6 and R is equal to 3. So this is 6C3 into 1 by 2 to the power 3 into 1 by 2 to the power 3. Over here, this 1 by 2 is the probability to have a girl, and this 1 by 2 is the probability to not have a girl, that is to have a boy, right? Now in this case, because both of them are equal, it's 1 by 2 to the power 3 and 1 by 2 to the power 3. Now if in the question it was said that the probability to have a girl is 2 by 3, then over here you would have 2 by 3 and this would have been 1 by 3. Alright, now when you calculate this, that is 63 into 1 by 2 to the power 6, right? That's 20 by 2 to the power 6, and that simplifies as 5 divided by 2 to the power 4, which is the same as 5 divided by 16, which is answer option B. Now, one more way to do this would be you can list down all the possibilities. If they have 6 children, all the 6 could be girls and you can have 0 boys, or it could be 5 and 1, or 4 and 2, 3 and 3, 2 and 4, 1 and 5, and 0 and 6. So these are all the possibilities, right? Now, over here, there is only one way in which you can have 6 girls and 0 boys, right? Because there's an order, right? Who is elder and who is younger. Now, over here, if you have 5 girls and 1 boy, you could have this happen in 6 ways, right? That's the same as having 5 G's and 1 B and finding the linear arrangements, which is 6 factorial by 5 factorial. Now, if it's 4, 2, that's 6 factorial by 4 factorial into 2 factorial. And if it's 3, 3, it's 6 factorial by 3 factorial into 3 factorial. 2, 4, 6 factorial by 2 factorial into 4 factorial. 1, 5, that's the same as 6, right? That's the same thing that we got over here. And 0, 6 is 1. So if you add all these up, you will get the total as 64. And you can see that 3, 3, there's 20 events in which this can happen. So favorable is 20, total is 64. Therefore, probability is 20 divided by 64, which is the same as 5 divided by 16. And that is answer option B. Let's read the next question. 4 students need to be selected from 10 students. Alright. To represent a school at a conference. Every student is equally qualified. Andy and Bob are best friends. If Andy is selected, what is the probability that Bob also will be selected? Alright, what's the answer to this question? The correct answer is option B, that is 3 by 9. Let's see how we get that. Remember, probability is favorable by total. Alright, now if Andy is selected, that's what is given over here, right? Then you just need to select 3 more students, right? Now in how many ways can you do that? You can do it in 9C 3 ways, because you have 10 students but Andy is already selected. So you're left with 9 more, and from those 9 you need to select 3. So that can be done in 9C 3 ways. So this is the total. This is the total number of ways in which it can be done. Now say Bob is also selected. So already 2 students are selected. You just need to select 2 more and from 8 children. So that can be done in 8C 2 ways. So these are the favorable cases, because in this case already Andy and Bob are selected. Therefore probability is favorable by total. That's 8C2 by 9C3, and 8C2 is nothing but 8 into 7 by 2. 9C3 is 9 into 8 into 7 divided by 3 factorial, which is 6, right? And that is 3 by 9 on simplification, or 1 by 3. And therefore your answer to this question is option B. Let's read the next question. A basket contains 5 yellow balls and 4 blue balls. 3 balls are drawn out at random from the basket. What are the odds in favor of all the 3 being blue? Alright, so we have discussed odds in favor and odds against, right? So what's the correct answer to this question? The correct answer is option A, that is 1:20. Now, what's the probability that all the 3 balls will be blue? You can select 3 balls from 4 blue balls in 4C3 ways. So this is favorable, right? And the total number of ways in which you can select 3 balls from 9 balls, right? 5 plus 4 is 9. That's 9C3. So this is total. So probability is favorable by total. That's 4C3 by 9C3. This simplifies to 1 by 21. Alright. Now remember, odds in favor is favorable events by not favorable events. So what does this mean, that probability is 1 by 21? It means that out of a total of 21 events, there is 1 favorable event, right? So favorable event is 1, and in this case, not favorable events are 21 minus 1, right? That's 20. So odds in favor is favorable events by not favorable events. In this case, that's 1 divided by 20, or you can write it as 1:20. And that is your answer, option A. Let's read the next question. 2 dice are thrown simultaneously. Find the probability that the sum of the 2 numbers that show up is less than or equal to 9. Alright, now what's the answer to this question? The correct answer is option D, that is 5 by 6. Now this is the easy way to solve this. it's finding the probability of the sum to be greater than 9, and then you subtract that from 1, right? You could do it the other way also, but that will take you more time, right? Because the probabilities of sum being greater than 9 is easy to calculate, because you just have 3 possibilities where the sum is greater than 9, right? Because the maximum in a die is 6, and the maximum in 2 dice together is 6 plus 6, which is 12. So greater than 9 is just 10, 11 and 12. If you want to check less than or equal to 9, you'll have to check possibilities from 2 up to 9. So that will take more time. So let's do it in the faster way. Now let's first find the probability for the sum to be greater than 9. So probability is favorable by all events, right? So for the sum to be 10, you can have 3 ways: 5 5, 6 4 or 4 6. For the sum to be 11, you have 2 possibilities: 5 6 and 6 5. Similarly, for the sum to be 12, there's just one possibility: both of the dice have to show 6. So that's 3 plus 2 plus 1. So you get 6 events in which the sum is greater than 9. So probability for the sum to be greater than 9 is 6 by 36, right? This 36 over here is 6 into 6, right? That's the total number of outcomes when you throw 2 dice. So 6 by 36 gives you 1 by 6. Now, for this not to occur, the probability is 1 minus 1 by 6. This is the complement, right? This is the complement of the sum to be greater than 9. Because over here you have less than or equal to 9, right? So you just need to find the complement of greater than 9 to find less than or equal to 9. So 1 minus 1 by 6 gives you 5 by 6. That's answer option D. Let's read the next question. I had with me 5 identical chocolates and 3 identical ice creams. 3 of my sister's kids asked me to give them something sweet, and I allowed them to take either a chocolate or an ice cream. What is the probability that 2 or more children chose chocolates? Alright, what's the answer to this question? The correct answer is answer option A. That's 1 by 2. Now, what are the total possibilities in this case? Each child, say this is child 1, this is child 2, and this is child 3. Each child can either choose a chocolate or an ice cream, right? So there are 2 outcomes possible for each child. Therefore, the total possibilities is 2 into 2 into 2, which is equal to 8. Now, in these 8 cases, the favorable cases are those in which either 2 children or 3 children choose chocolates. Now 3 children choosing chocolate can be done only in one way. That's C, C and C, right? C stands for chocolate. Now 2 children choosing a chocolate and the remaining 1 person choosing an ice cream can be done in these 3 ways. You can think of it as even 3 factorial by 2 factorial, right? This could be also thought of as 3 factorial by 2 factorial, because 2 are of one kind. So you have 3 items. So linear arrangements is 3 factorial by 2 factorial, which is also equal to 3. So there are 4, that's 3 plus 1, 4 favorable events. Therefore, the probability for this to happen is favorable by total, that's 4 by 8, which is equal to 1 by 2, and that is answer option A. Let's read the next question. A number is selected at random from the first 50 natural numbers. What is the probability that it is a multiple of 5 or 7? What's the answer to this question? The correct answer to this question is 8 by 25. That is answer option B. Now let's think about this a little bit. Now over here you have the first 50 natural numbers. That's 1, 2, 3, etc. up to 50. Alright. Now we need to check that the number that is selected is a multiple of 5 or 7. Alright. So how many favorable events are there? Let's try to find that out. Now over here the number of multiples of 5 in the first 50 numbers is 50 by 5, which is equal to 10, right? If you need to find the number of multiples of number x in the first y numbers, you just need to do y by x. That's what we've done over here, right? And which are these 10 numbers? You'll have 5, then you'll have 10, you'll have etc. up to 50, right? So this is 5 into 1, this is 5 into 2, and etc. up to 5 into 10. So that's why you'll have 10 numbers over here which are multiples of 5, right? Similarly, the multiples of 7 will be 50 by 7, which is equal to 7. So that's 7, 14, etc. up to 7 into 7, which is 49. So you'll have 7 numbers which are multiples of 7. And it does not end over there. You'll also have to check multiples of 5 and 7. So 35 is a multiple of 5 and 7, right? So 5 into 7 gives you 35. So in 50, there is one multiple which is a number which is a multiple of 5 and 7. So let's quickly draw a Venn diagram to understand this better. Let me draw that over here. Say this represents the multiples of 5 and this represents the multiples of 7. And over here we have all the 50 numbers inside this box over here. So the multiples of 5 we have seen over here are 10, right? We have 10 numbers over here, and the multiples of 7 are 7, right? But you can see there is an overlap. So if you do 10 plus 7, you will be counting whatever is coming inside this part 2 times. That's why we have to subtract it once. So the favorable events is 10 plus 7 minus 1. So 10 plus 7 minus 1 is the favorable events, that's 16. And the total events is, you can choose any one out of the 50 numbers, which is 50C1, which is nothing but 50. Therefore, probability is favorable by total, which is equal to 16 by 50, or that is the same as 8 by 25, which is answer option B. Let's read the next question. 2 dice are thrown simultaneously. What is the probability of getting an odd number on both the dice? Alright, what's the answer to this question? The correct answer is option A, that's 1 by 4, right? These two events, that is the first dice and the second dice, these are independent events, right? So the probability of getting odd on the first die is 3 by 6. The probability of getting odd on the second die is also 3 by 6. And the probability of getting odd on the first die and getting an odd number on the second die is 3 by 6 into 3 by 6, right? When you have and, you need to multiply. That's 1 by 2 into 1 by 2, which is equal to 1 by 4. That is your answer. Remember, which are these 3 events where you can get an odd number? That's 1, 3 and 5, right? Alright, let's move to the next question. 5 boys and 4 girls are randomly seated in a straight line. Alright, find the probability that no 2 girls are sitting next to each other. Alright, what's the answer to this question? The correct answer is option A, that's 5 by 42. Alright, let's see how to do this. Remember, probability is favorable by total. Alright, now how many total arrangements are possible? You have 9 people, right? There are 5 boys and 4 girls. So that's a total of 9 people arranged in a straight line that can be done in 9 factorial ways. Alright, now let's see the favorable cases. Now first let's seat the boys. So that's 1, 2, 3, 4, 5, right? 5 boys are seated in these 5 places. So they can be arranged in 5 factorial ways. Now over here, I've marked all the places where girls can be seated so that no 2 girls are sitting next to each other. So there are 1, 2, 3, 4, 5, 6. 6 places are there, right? And we have 4 girls. So 4 girls can be seated in 6 places in 6p4 ways, right? And 6p4 is 6 into 5 into 4 into 3, and that's equal to 360. Alright, now therefore the answer is 5 factorial into 360, right? This is the favorable cases. You have seated the boys and you have seated the girls. So that's 5 factorial into 360 divided by 9 factorial, which is the total arrangements of the 5 boys and 4 girls. And this simplifies to 5 by 42, which is answer option A. Let's read the next question. 2 dice are thrown. What are the odds against getting a sum of 8? Alright, so what's the answer to this question? The correct answer is option A, that is 31:5. Now let's think of this question. Now what are the ways in which you can get a sum of 8? When you throw 2 dice, you could get 6-2, 5-3, 4-4, 3-5 and 2-6. So there are 5 ways in which you can get a sum of 8. And if you throw 2 dice, what are the total possibilities That's 6 into 6, which is equal to 36. Now in this question, we need to find odds against, right? What is odds against? It's the number of events in which you don't succeed, right, divided by the number of events in which you succeed or the criteria is met. Now in this case, you have 5 ways in which the criteria is met, so that's your denominator, and in your numerator you need to find the cases in which the criteria is not met, right? That is total minus the favorable situations. So that's 36 minus 5 divided by 5, or 31 is to 5, and that is answer option A. Let's read the next question. What is the probability of getting at least 1/6 when two unbiased dice are thrown? So whenever you throw these two unbiased dice, right, these are independent events, right? So what's the answer? The correct answer is answer option C. That's 11 divided by 36. Now you need to find the probability of getting at least 1/6. The easy way is you find the probability of getting no 6 and then you do 1 minus that probability. So when you get no 6, the first die you can have 5 favorable events out of 6. So that's a probability of 5 by 6. Similarly, 5 by 6 is the probability for the second die as well. Therefore, the probability to get no 6 when two dice are thrown is 5 by 6 into 5 by 6, which is 25 by 36. Now, the probability to get at least 1/6 is 1 minus 25 by 36, which is 11 by 36, and that gives you answer option C. Alright, let's read the next question. A child is trying to play a musical piece perfectly on the violin. She fails twice as often as she succeeds. What's the probability that in the next 3 trials she succeeds 2 times? So this is a clear application of NCR P to the power R Q to the power N minus R, right? What's the answer to this question? The correct answer is option C, that is 2 by 9. Now over here, it's mentioned that she fails twice as often as she succeeds. Therefore, the probability of success is 1 out of 3, right? The probability of failure is 2 out of 3 trials. Now, in the next 3 trials, she has to succeed 2 times. So over here, N is equal to 3 and R is equal to 2. So you get 3C2 into 1 by 3, which is the probability of success to the power 2, right? Into 2 by 3 to the power 3 minus 2, which is 1. Now 3C2 is nothing but 3, right? 3C2 is equal to 3C1 and that's equal to 3. And over here you have 1 by 3 square into 2 by 3. This simplifies to 2 by 9, which is answer option C. Let's read the next question. 3 integers are chosen randomly. What is the probability that these 3 will have the same unit digit and that the product of these 3 integers will also have the same unit digit? Alright, what's the answer to this question? The correct answer is option D, that is 6 by 1000, right? Over here, the criteria is unit digit into unit digit into unit digit should give you the same unit digit. So which all numbers satisfy this condition? Remember, unit digit always depends only on unit digit. That's why I'm not taking the other numbers into consideration. What do I mean with that? Take any multiplication, 23 into 42 into 73. The answer of this multiplication will have a unit digit which is 3 into 2 into 3, right? So 3 into 2 is 6, 6 into 3 is 18. So 8 will be the unit digit of this multiplication. Therefore, unit digit only depends on unit digit. Alright. Now over here it's mentioned that unit digit into unit digit into unit digit should give the same unit digit. So these are equal and it's equal to this also. So 0 satisfies it, right? 0 into 0 into 0 will give you 0. 1 into 1 into 1 will give you 1. So that's also satisfying. 2 into 2 into 2, that's 8. So that does not satisfy. 3 into 3 into 3, that's 27. So that's 7, right? Unit digit is 7. It does not satisfy it. 4 into 4 is 16. 16 into 4 is 64. So yes, the unit digit is again 4. So it satisfies. In this manner, you can see that 0, 1, 4, 5, 6 and 9. In these cases, this criteria is satisfied, right? 6 also, 36 into 6, again it will have 6 as the unit digit. What about 9? 9 into 9 is 81. 81 into 9 also will have 9 in the unit digit. All right. So you have 6 possibilities and the unit digit could be any of 10 digits, right? 0 to 9 is 10 digit. So the probability to be one of these as the unit digit is 6 divided by 10, right? So that's the way in which you choose one. Now, this unit digit also has to be the same unit digit that you choose over here. So that probability is 1 divided by 10, right? That one, this one over here could be any of 10 digits. So you have already chosen one over here. So for these two to be equal, there is only one favorable case and there are 10 possibilities. So the probability is 1 by 10. And for the third unit number also, for it to have the same unit digit, the probability is again 1 by 10. Therefore, the answer is 6 by 10 into 1 by 10 into 1 by 10, which is 6 by 1000. That's answer option D. Let's read the next question. Pinocchio speaks the truth once every 3 times. Alright, once every 3 times. He throws a dice and says it's a 4. Find the probability that it is a 4. Alright, what's the answer to this question? The correct answer is answer option A. That's 1 by 18, right? Now, for it to be a 4, 2 events have to occur, right? The first one is that he actually got a 4 and the second event is that he spoke the truth. Now, he can get a 4 in 1 by 6th of a chance, or the probability to get a 4 is 1 divided by 6, right? And the probability that he speaks the truth is 1 by 3 because it's mentioned that he says the truth once every 3 times. Now, therefore, the probability for these two events to occur, right? These are independent events, right? That would be 1 by 6 into 1 by 3, which is equal to 1 by 18. That is answer option A. Let's read the next question. 5 boys and 4 girls are randomly seated in a straight line. Find the probability that all girls are sitting next to each other. Alright, now what's the answer to this question? The correct answer is option C, that is 2 by 42. Alright, now over here you have 5 boys and 4 girls. So that's a total of 9 people and they can be arranged in a straight line in 9 factorial ways. Alright, now let's try to find the favorable scenarios. Now for this, let's treat the 4 girls as one unit because they are sitting next to each other, right? So you have a total of 6 units, that is 5 boys and 1 unit, which is the 4 girls taken together. So 6 units can be arranged in a straight line in 6 factorial ways, right? Now this 1 unit comprises of 4 girls, right? So these 4 girls among themselves can be arranged in 4 factorial ways because they are also in a straight line, right? Therefore, the favorable cases is 6 factorial into 4 factorial. And probability is favorable by total. So that's 6 factorial into 4 factorial by 9 factorial. And this simplifies to 1 by 21, which is the same as 2 by 42, which is answer option C. Let's read the next question. 2 movies A and B are running in a theater. 25% of all visitors to the theater are buying tickets for movie A and remaining for B. What is the probability that 3 out of 4 people who enter the theater at 10 a.m. buy tickets for movie B? Alright, so what's the answer to this question? The correct answer is option C, that is 27 divided by 64. Now, it's given that the probability for somebody to buy a ticket for movie B is 3 by 4 and probability for A is 1 by 4, right? Because it's mentioned that 25% of the visitors buy tickets for A and 75 buy for B, right? Because the remaining buy it for B. Alright, now over here we need to find that 3 out of 4 people buy tickets for movie B. So this is a clear application of NCR P to the power R Q to the power N minus R. N is equal to 4, R is equal to 3, P is equal to 3 by 4 and Q is equal to 1 by 4, and over here that's 4C3 into 3 by 4 to the power 3 into 1 by 4 to the power 1. This simplifies to 27 divided by 64, which is answer option C. Let's read the next question. Clement selects a 2-digit number at random. What is the probability that this will not be a multiple of 7, will not be a multiple of 2, and will be a multiple of 3? Alright, what's the answer to this question? The correct answer is answer C. That's 13 divided by 90. Alright, now over here he's selecting a 2-digit number, right? So we know that he's selecting a 2-digit number. So how many multiples of 3 are there in the set of 2-digit numbers? You will see that there are 30 numbers, right? Over here, the first 2-digit number, that's a multiple of 3, is 12, right? The next one will be 12 plus 3, which is 15, and it goes on till 99, right? 99 is divisible by 3. So 12 is 3 into 4, 15 is 3 into 5, 99 is 3 into 33. So 4, 5, etc. up to 33. So if you count that, you just need to subtract 3 from 33. So the count over here is 30. So there are 30 multiples of 3 that are 2-digit numbers. Alright. Now how many numbers are there that are multiples of 3 and are multiples of 2? Because they should not be multiples of 2, right? So we need to subtract them from 30 to find the actual favorable cases. So multiples of 3 and 2 is nothing but multiples of 6. So the first 2-digit number, which is a multiple of 6, is 12, and it goes on till 96. So how do you find this 96? One way of there are multiple ways. One way is you just do 100 divided by 6, right? 100 is the smallest 3-digit number. When you do 100 divided by 6, that goes once, you have 6, and then you have 4 remainder, that's 6, 36. You have a remainder of 4, right? So 100 minus 4 is a multiple of 6, and 100 minus 4 is 96. So that's one way in which you can find this. Alright, so over here you can see that that's 12 is 6 into 2, 18 is 6 into 3, up to 96, which is 6 into 16. So that's a total of 15 numbers which are multiples of 6 and 2-digit numbers. Alright, another way to arrive at this 15 over here is if you take 90 divided by 6, right? 90 divided by 6 also gives you 15, because there are 90 2-digit numbers. The first 2-digit number is 10 and the last 2-digit number is 99. So there are a total of 90 2-digit numbers, and in 90 2-digit numbers you'll have 90 by 6, that's 15 multiples of 6. Alright, now let's proceed. Now let's find the 2-digit multiples of 3 and 7. So that's multiples of 21. 3 into 7 is 21. So that's 21, 42, 63 and 84. You can just write it down like 21. 21 plus 21 is 42. 42 plus 21 is 63. 63 plus 21 is 84. So there are just 4 numbers which are multiples of 3 and 7. And we also need to check multiples of 3, 2 and 7. That's multiples of 42, right? 3, 2 and 7, if you multiply it, you will get 42. So you have just 2 over here. Now over here the favorable events is 30 minus 15 minus 4 plus 2, right? Why is that so? You need to add 2 because this will be subtracted 2 times. Let's try to understand that. Imagine that this over here represents all the 2-digit multiples of 3. So that's 30 numbers are there inside this box. Now inside this box, let's draw a circle to represent the multiples of 2, and remember, because it's inside this box, it will be multiples of 2 and 3. So these are the 15 numbers that we found over here. Now if I draw one more circle, that represents the multiples of 3 and 7, right? And there is an intersection over here. These are multiples of 3, 2 and 7. They are multiples of 2 and 7 because these two circles are intersecting and they are inside this box, right? Remember, this box was all the multiples of 3. So this is multiples of 2, 3 and 7. So this is subtracted 2 times. If you do 30 minus 15 minus 4, and if you stop there, you will be subtracting this part 2 times. But we just want to subtract this part 1 time because we just need to find this outside area. That is, this outside area is multiples of 3 which are not multiples of 2 and not multiples of 7, right? Therefore, the favorable cases is 30 minus 15 minus 4 plus 2, that's 30, 13, right? And the total cases is 90. There are 90 2-digit numbers, so 90. Therefore, the probability to find a number, to select a number which is a multiple of 3 and not a multiple of 2 and not a multiple of 7 is equal to 13 by 90, which is answer option C. Let's read the next question. A basket contains 14 green and 20 red apples. 1/7 of each of these is rotten. 2 apples are picked one after another at random from the basket. What is the probability that both are not rotten? Alright, what's the answer to this question? The correct answer is option B, that is 36 into 35 by 42 into 41. Alright, over here it's given that you have 14 green apples and 28 red apples, right? And 1/7 are damaged. So 1/7 of 14 is 2 and 1/7 of 28 is 4. So the apples which are not rotten is 14 plus 28 minus the rotten, right? Minus 2 minus 4. So that's 36 apples which are not rotten. So we just need to pick 2 apples from these 36 apples. So to pick one in the first go, you have a probability of 36 by 42. Now already one is picked. So you're just left with 41 more apples, and we are taking that it's picked from this set, that is a not rotten apple. So in 36 only 35 are remaining. Therefore the probability to pick 2 apples one after the other in which both are not rotten is 36 into 35 by 42 into 41, which is answer option B. Let's read the next question. Carol and Kathy throw 2 dice each. The sum of the numbers Kathy got is 10. Alright. Find the probability that Carol will get a higher sum. Alright. What's the answer to this question? The correct answer is option C, that is 3 by 36. Alright. You need to get a sum greater than 10, right? Now what are the possibilities? You can get 11 when you throw 2 dice and you can get 12 when you throw 2 dice. Now to get 11, there are 2 possible events. You could get 5 and 6 or 6 and 5, right? Now to get 12, there is only one possible event. That is the event where both the dice show 6. Now hence 2 plus 1, that's 3. So you have 3 favorable events. Therefore the probability is 3 by 36 or 1 by 12, and that is answer option C. Let's read the next question. 6 out of 10 children passed the math exam. Alright. They come out of the classroom one by one. What is the probability that the 8th person coming out is the last person who passed? Alright. What's the answer to this question? The correct answer is answer option A, that is 1 by 10. Now let's think about this. Now for this to be true, when the first 7 persons come out, 5 should have passed and 2 should have failed, right? Then only when the 8th person comes out, we can choose him such that he has passed, and in that case this criteria mentioned in the question will be satisfied. Alright, now let's first think of this scenario. What's the probability for this to occur? Now you need 5 people to pass, right? And you have 6 people who passed. So you can select 5 from those 6 people in 6C 5 ways. And from the remaining 4 who failed, you can choose 2 in 4C 2 ways. So this can be selected in 6C 5 into 4C 2 ways. Alright. And the total number of ways in which you can select 7 out of 10 people is 10C 7. So the probability for this to happen is 6C 5 into 4C 2 by 10C 7. So that's the first part over here. Now the 8th person has to be chosen only in one way. This is the favorable, right? He has to have passed. So the favorable in this case is 1, and the total number of ways in which you can choose the 8th person is 3C1, because you are left with 3 more people, right? Out of 10, 7 have come out, so you're left with 3 more. Out of those 3, you need to select 1. So that can be done in 3C1 ways. So the probability for the 8th person to have passed is 1 divided by 3C1. Therefore, the probability for the criteria mentioned in the question is 6C5 into 4C2 by 10C7 into 1 by 3C1. And this simplifies to 1 by 10, which is answer option A.